Hey guys, welcome back to Toon Blend 3D. In this tutorial, we're going to create a Crocogun stylized weapon in Blender, and at the end, we'll export it to Godot. Alright, let's start with the modeling part first. Before we start modeling, we need to import the reference images. You can get it from this channel's Pinterest account. To add a reference image, press Shift plus A, then choose Image Reference. Select the reference image and click OK. Press G to move the image reference. Then press Z to lock the movement to the vertical axis so it moves only up and down. Since this reference image is quite long, adjust the position so the front part sits slightly above the bottom axis line. You can also adjust the opacity of the reference image. Go to the Object Properties tab on the right side of the layout. Enable opacity, then adjust the value next to it. Use the mouse scroll up and down to zoom in and out. Now move your mouse pointer to the layout view and press F2 to rename the image reference. Rename it to Front, because we'll use this for the front view. Next, duplicate it by pressing Shift plus D. You can hide the previous front image reference first to make it easier to adjust the new one. Just click the eye icon on the image object to disable its visibility. Then adjust the position so the other front reference lines up exactly with the first front reference we placed earlier. Rename this reference to Front Inside and rename the previous one to Front Outside. This helps us see the internal modeling details more clearly, and it will also make it easier later when we set up the pose. Next, press Shift plus D again to duplicate it for the top reference. Rotate it by pressing R, then press X to lock the rotation axis sideways. Type 90 to set the rotation angle. Then press minus to flip the rotation direction. Now change the view by pressing the backtick key on your keyboard, then choose Top View. After that, adjust the reference image so the top view image aligns symmetrically with the horizontal coordinate axis. You can use the middle mouse to control the movement direction. Then rename the reference to Top. After setting up all the references, rename the collection group to Refs. Then right-click and create a new collection and name it Mesh. This will be used to store all the mesh objects we're going to model later. And that's it for the reference setup. Now we're ready to move on to the next step, which is modeling. First, decide which part you want to create first. Here, I'm going to start with the inner part, so we'll only enable the front inside reference. Before starting, click on the mesh collection so any new object we create will automatically go into that collection. Now let's create the main barrel of the Crocogun. Press Shift plus A, then choose Mesh, Cylinder. Set the vertices to 12. By default, the ends of the cylinder are closed with faces. Here, we want them open, so change the cap fill type to Nothing. Quick tip: if you accidentally close or lose the Mesh Settings panel before finishing, you can bring it back by pressing F9. This will reopen the last used settings panel. Next, switch from Object Mode to Edit Mode. Press S to scale the cylinder, then adjust the position to match the reference image. Enable X-ray mode from the top right so you can still see the reference image even when it's covered by the mesh. Now change the selection mode from Face to Edge, located at the top left of the screen. Select the edge at the end of the cylinder and make sure X-ray mode is still enabled. Then move it to match the reference or your desired shape. After that, press Ctrl plus R and hover over the mesh to add an edge loop. Then slide it into position following the reference. Hold Shift to slow down the movement. Next, we're going to make the end of the cylinder a bit more protruding. Switch the selection mode to Face, then hover your pointer over the face loop at the end of the cylinder and click while holding Alt. This will automatically select the entire face loop. After that, press Alt plus E and choose Extrude Faces along normals. This will push the face loop outward. Adjust the scale by moving your mouse and hold Shift to slow down the movement for more precise control. Then select the edge loop at the end of the cylinder and move it backward to create a slanted edge or chamfer on the tip. Next, select both edge loops at the ends of the cylinder. Press Alt to select an edge loop and hold Shift to select multiple loops. Then press E to extrude and press S to scale. You'll notice the scale goes inward instead of staying straight. Press Slash to isolate or focus on the selected mesh object. This happens because the transform pivot point is set to median point. So when scaling to edge loops, it moves toward the center point between them. So let's change the transform pivot point to individual origins. You can find it at the top center of the layout, or you can also press period to bring up the pivot options right at your cursor. Now, let's try again. First, delete the previous edge loop by pressing X and choosing vertices. This time it works correctly. Using individual origins is really helpful when extruding or scaling multiple edge loops at once. Press Slash again to return from the isolated view. Then go back to front view to make it easier to adjust the scale of those edge loops based on the reference. while keeping X-ray mode enabled. Next, let's try adding faces to the inner part of the cylinder. First, select an edge on one side, then select the opposite edge and make sure they are aligned, then press F to create a face connecting those two edges. After that, select the side edges and press F again to automatically fill the faces. Keep pressing F until the entire inner circle of the cylinder is fully closed. Then press A to select all vertices. Press M and choose by distance. This ensures there are no duplicate or overlapping vertices. Once we finish the first part of the cylinder barrel, we can move on to the next step. Select the edge loop at the inner diameter opening of the cylinder, then duplicate it by pressing Shift plus D. Continue by extruding and shaping the length of the cylinder to match the reference. Then add an edge loop in the middle by pressing Ctrl plus R. After that, press Ctrl plus B to bevel the edge loop into two segments. If it's still not enough, you can adjust the spacing by pressing S to scale. Then lock the axis direction using middle mouse along the length of the cylinder. Hold Shift to slow down the scaling movement for better precision. Next, press Alt plus E and choose Extrude Faces along normals. Then push the extrusion inward. Press L to quickly select all connected faces in a separated mesh part. Then press Shift plus H to isolate the selected faces and hide the rest. Now we'll work on the inner part of the cylinder. Extrude again, and here I want to match the diameter with the one in the middle section. Enable snapping, set snap base to active, and snap target to vertex. For effect, enable move, rotate, and scale. Try scaling first. If it doesn't work as expected, press G twice. Then move the active vertex toward the target vertex you want to match. For the other side, you can simply press Shift plus R to repeat the last action. Don't forget to turn off snapping after you're done so it doesn't interfere with the next steps. Continue extruding, then connect the two edge loops. Right-click, go to Loop Tools, and choose Bridge. Make sure both edge loops are selected. Next, continue building the next section of the cylinder casing using the same steps as before. For this part, we'll close the back end with a face. Select the edge loop at the back, press M, and choose at center. This will merge the loop into a single point. For the front end, extrude slightly inward first before merging its center. Press Alt plus H to unhide the previously hidden vertices. Then select the protruding circular face area by holding Shift plus Alt in face selection mode to select multiple faces at once. Press S to scale. Use middle mouse to lock the axis sideways. And make sure the transform pivot point is set to individual origins so each face scales inward properly. Next, select the cylinder tip by pressing L and activate snapping with vertex active like before. Select the vertex at the tip that you want to align, then move it sideways using middle mouse and snap it to the target vertex. Repeat the same step for the middle part of the cylinder. Before moving on, I'll change the viewport, shading, lighting, and enable cavity, so the wireframe lines appear more visible even without turning on wireframe in the viewport overlays. And with that, we've finished modeling the cylinder casing of the Crocogun. Before moving on to other parts, we're going to create shape keys. This allows us to adjust vertex movement without changing the original mesh shape. Go back to Object Mode, then in the Shape Keys panel, click the plus icon to add a new shape key. The first one is the basis, which keeps the original shape of the mesh. The second one is where we can modify the mesh shape without affecting the original, although there are still some cases where it can be influenced. First, we'll adjust the basis shape key. Switch to Edit Mode, then make the cylinder in a closed position. Next, switch to the first shape key and make the middle part of the cylinder move outward. Go back to Object Mode, then adjust the value slider to preview and control the shape key movement. Now, duplicate the first shape key using the drop-down arrow in the Shape Keys panel, then choose Duplicate Shape Key. You'll notice that the duplicated shape key makes the middle cylinder separate even more. This happens because the duplicated shape key copies a movement from the first one, and since both are active, the lower one keeps adding the transformation on top. To fix this, change the relative to setting of the duplicated shape key from basis to the first shape key. Now the duplicated shape key will use the first shape key as its reference. Then adjust the duplicated shape key so the end part of the cylinder moves outward, similar to the middle section. Go back to Object Mode and adjust the value to see the result. Just a quick reminder, shape keys behave differently when exported to Godot. In Godot, shape keys only work relative to basis, so any shaped key that doesn't use basis as its reference, like this duplicated one, will automatically fall back to basis, and the result may look the same as before. So if you plan to export to Godot, it's best to keep all shape keys set to relative to basis. You can rename shape keys by double-clicking on them, and you can also lock them. When a shape key is locked, you won't be able to edit the mesh in edit mode. However, you can still add edge loops using Ctrl+R, even if the shape keys are locked. Now, let's try creating a new shape key. Then try beveling the end of the cylinder using Ctrl+B. After that, adjust the shape key value, and you'll notice it doesn't affect the bevel result. Now, check the base's shape key to see if it's affected, and yes, it is, even though the base's shape key is locked. Next, let's test by extruding an edge loop. You'll see that the shape key value does affect the result. Now try duplicating the shape key, then add an edge loop and scale it. You can see that the shape key value still works in this case. Then delete both shape keys by clicking the minus button. Now let's test whether the bevel, extrude, edge loop, and scale changes will disappear after removing the shape keys. Check the base's shape key, and don't forget to unlock it. As you can see, the bevel, extrude, and edge loop results are still there even after deleting the shape keys. Now remove the extra edge loops and do a merge by distance by pressing M. For the bevel part, I'll just leave it as it is. Then here, I'll refine the shape again to better match the reference. And with that, the cylinder casing of the Crocogun is finished. Next, we'll continue with the other inner parts. Now, let's move on to this part. Add a new cylinder just like before in object mode. Then adjust the scale and rotation to match the reference. Select both edge loops at each end of the cylinder, then extrude them. Temporarily change the transform pivot point to median point, then scale and move it sideways. This will stretch the edge loops outward in opposite directions. After that, switch the transform pivot point back to individual origins and adjust the scale of both edge loops. Now select the face loop in the middle of the cylinder, duplicate it, and hide it for now. Select the original face loop again, then press Alt+E and choose Extrude Faces along normals, pushing it inward. Press Alt+H to unhide the previous faces. Next, select the edge in the middle and split it into two, using Ctrl+B. Before that, enable X-ray mode so you can clearly see the reference. And you can switch the front reference if needed for better visibility. Scale it up along the Z-axis, then adjust the width to match the reference. Add 3 edge loops in the middle using Ctrl+R and scroll the mouse. Press K to activate the knife tool. This is used to manually cut lines across faces. Create a zigzag pattern in the middle based on the reference. Then select the zigzag edges and press V to rip or separate them. Before continuing, delete one side of the mesh. Then add a mirror modifier. Go to the right panel, click Add Modifier, go to Generate, and choose Mirror. And don't forget to enable clipping so vertices along the center line will merge together properly. Next, adjust the scale from the top view to match the reference. Then for each end of the cylinder, extrude and scale inward. After that, merge them at the center and move them toward the middle. Select both end faces of the cylinder and press I to inset. Then delete the inner faces and select the middle edge loop and move it back toward the center. Next, select the cover face area in the middle. Then select the 2 triangle faces at the bottom. Switch to right view, then rotate them by -10 degrees so they open outward. This depends on your current view orientation. Do the same for the triangle faces at the top. Then select both triangle faces, go to right view, and align them with the bottom vertices using Vertex Active Snapping. Next, select all vertices and extrude faces along normals inward. Then press P and choose Selection to separate the mesh. Switch to Object mode, and now we'll create shape keys for this cover part. Go into Edit mode, select the center part of the cover from the right side, then press Shift+S and set cursor to selected. Now select the top triangle face first. Press period and change the transform pivot point to 3D cursor. Then press R and rotate it by 35 degrees. After that, position it correctly using snapping. Repeat the same step for the bottom triangle face. Go back to Object mode and test the shape key by adjusting its value. Finally, check the inner part and use Alt+S to adjust the scale if needed. And with that, this part is finished. Now, let's move on to the top section. Select both meshes, go into Edit mode, and select the top faces, then duplicate them, separate, and join them into a single mesh using Ctrl+J. Go back to Edit mode, then try to extrude faces along normals. But here, the extrusion direction is flipped. As a workaround, you can press G then Z to move it upward. But let's redo it and understand why this happens. Enable face orientation in the viewport display settings. you'll see two colors. Blue means correct face normals, and red means flipped normals. So now let's fix it so all faces are blue. Go to Edit Mode and press Shift+N to recalculate the normals. If the face orientation still flips, check the mesh. In this case, the vertices are not properly merged. So first, merge them using Merge by Distance, then press Shift+N again. Now the face orientation should be correct. Repeat this step if needed for other parts of the mesh. Once done, disable face orientation again, then continue extruding the top faces along normals. You'll notice that when the normals are correct, the extrusion direction also behaves correctly. After matching the reference, delete the left half of the mesh and add a mirror modifier on the X, Y, and Z axes. However, you might notice the mirror result is not aligned as expected. This usually happens because of the mesh origin position. The mirror modifier uses the origin as its reference point. Since the origin is still at the default world origin, the mirror behaves incorrectly, so we need to move the origin to the center of the mesh. Earlier, we placed the 3D cursor at the center, so now we can use that. Go back to Object Mode, right-click, choose Set Origin, then select Origin to 3D Cursor. Now, the mirror should work correctly. Finally, continue adjusting and shaping the mesh to match the reference. Next, we'll shape the bottom part by using the base from the mesh above. Duplicate it, then apply the mirror modifier. Go into Edit Mode and delete the top part. Besides using X, you can also press the Delete key on your keyboard. Then extrude it downward and flatten it by pressing S, Z, 0. After that, delete the side faces and add a mirror modifier again. The reason I'm using mirror here is because I want the texture to be symmetrical on both sides. If you want different textures on the left and right, then you don't need to use a mirror on the mesh. Now, let's continue shaping the bottom part. Take one face from the previous mesh, extrude it, and rotate it to match the reference. Since we want to merge it later, don't forget to delete the inner faces. Continue shaping the bottom part, and always check from different views. You can also edit multiple meshes at once by holding Shift. To select them in Object Mode before entering Edit Mode. Next, let's create the trigger. Since we need more geometry, add 2 edge loops. If the left side doesn't match the right side, a quick fix is to delete the left side and enable X-axis in the mirror modifier. Select some faces, then duplicate and separate them to create the trigger mesh. Apply the mirror modifier, then delete the side faces and one vertex. Add another mirror modifier so it only mirrors sideways. Then extrude and shape it to match the reference, checking from different views. After that, create the shape keys for the trigger. set it up like the reference and test it once done. Now let's move on to creating the bolt. First, take one face, then duplicate and separate it. Go into Edit mode, right-click and choose Subdivide. This will automatically add more edges to the face. Then, right-click again, go to Loop Tools and choose Circle. This will turn the face into a circular shape. Scale and position it. Then extrude it, following the reference. For the middle part, duplicate the bolt, delete some parts, then combine it by moving everything toward the center. After finishing the bolt, let's move on to the back part. While still in Edit mode, press Alt plus Q to switch between meshes by pointing your mouse at the mesh you want to select. Then select the face, duplicate it, and separate it. Apply the mirror modifier, then delete the vertices on the right side since we don't need them. Also delete some unnecessary parts and add the mirror modifier again. After that, continue extruding and shaping it to match the reference, and make sure to check it from all angles. For the middle part, we'll try to extrude it. Before that, disable clipping in the mirror modifier. Then connect the top and bottom faces using Loop Tools Bridge. This will automatically fill the faces between them. Next, separate the middle part, then fix or fill any missing faces. Continue shaping it until it matches the reference. Once that's done, we'll create the inner part by adding a cylinder mesh. Set the vertices to 12, and for fill type, keep it as triangle fan. Before scaling in Edit mode, make sure to turn off snapping. First, make the cylinder longer. The length doesn't have to be exact at this point. Then add one edge loop in the middle and split it into two using Ctrl plus B. Next, press Alt plus E and choose Extrude Faces along normals, pushing it inward. Add two more edge loops in the middle and adjust their spacing. Then scale using Alt plus S so the length stays consistent. Continue adding edge loops in the middle and adjust the scale as needed. If it looks too long, select all vertices and scale it sideways to make it slightly shorter. Now create the tip section based on the reference. Adjust the length of the tip cylinder, then select the end circle and duplicate it. Extrude and scale repeatedly to build the shape according to the reference, and for the final part, merge it at the center. After that, tilt it slightly to match the reference and adjust the scale if needed. Then adjust the position from the top and left views. Once everything looks good, add a mirror modifier. For the cone tip part, you can separate it into its own mesh. Next, let's create the handle of the Crocogun. We'll use a cylinder with 12 vertices and triangle fan caps. Scale and shape it, make the bottom part larger than the top, and give it a slight curve. After that, extrude the bottom part to match the reference. For the bottom surface of the cylinder, inset it to create a circular shape, then extrude it inward. After that, flatten it using Loop Tools. Then continue by adding some variations. And for the top cap of the handle, delete it. Now let's create the claw or fang details on the circular area at the bottom of the handle. Since there are 3 claws, we'll prepare 3 faces. Split the center face using Ctrl plus B, then adjust them so all 3 faces have equal size. After that, add an edge loop in the middle. Then select the 3 faces and use Loop Tools Circle to make them more rounded. Shape the faces so they look naturally curved. Select the 3 circular faces again, then inset them by pressing I. Adjust your view, then extrude and scale at the same time. select the center face, rotate it from the side, then extrude again, and merge it at the center for the tip. For the other two faces, switch the transform orientation to normal to make rotating them together easier. Repeat the same process as the center one, then making sure all three claws have a consistent size. After that, delete one side and add a mirror modifier. Then rotate and position it according to the reference. Before that, you can use shape keys to preserve the current shape and position. When checking, you might notice the mesh origin is not centered. To fix this, move the cursor to the world origin, go back to object mode, right-click, and set origin to 3D cursor. Return to edit mode, then adjust the mesh so everything connects properly toward the center. Continue refining the shape to match the reference. Since we added shape keys earlier, these changes are applied to shape key 1 instead of the bases. To make shape key 1 become the new bases, first, delete the bases shape key, then delete shape key 1. This way, the mesh is clean again without any shape keys. Then continue refining the mesh if it still needs adjustments. For the claw or fang parts, you can make them longer by scaling using transform orientation set to normal, and move along the z-axis. This will make the claws look sharper and more pointed. Or you can also make them slightly uneven in size or scale to give a more wild and natural look. Next, let's create the handle wrap. First, add an edge loop on the handle, then duplicate and separate the face loop. This will be used as the wrap. Then adjust and shape it to match the reference, making sure no faces overlap. Add a solidify modifier to give the mesh thickness. After that, duplicate it multiple times and place them one by one to wrap around the handle like in the reference. Can add a subdivision modifier to make it smoother, but keep in mind, this will increase the vertex count significantly. Also, the order of modifiers affects the final result, so make sure to check that. Continue adjusting the vertex positions carefully so nothing overlaps. Now let's create the hanging strip from the handle wrap. Duplicate the front edge, then move it slightly to the side. Make sure to temporarily disable clipping in the mirror modifier. Then extrude it once, select all vertices, and press Shift plus E to apply edge crease so it won't be overly affected by the subdivision modifier. Adjust the position and rotation, then extrude again and set the length. You can control the edge crease value from the Edge Data tab in the Item panel. Continue shaping it to match the reference by adding more edge loops. Then create a pointed tip in the middle like a ribbon by adding an edge loop in the center. Adjust the shape so the connection area becomes smaller in scale. Tweak it so the curve looks natural, like it's being pulled by gravity. Next, let's create the crocodile head. Start by adding a plain mesh, then delete half of it and add a mirror modifier. Begin shaping it from the top view first. Start from the center, then extrude and follow the reference shape all the way to the tip of the head. Then switch to front view and adjust the circular vertex loop for the nose. Select the nose loop, extrude it inward while slightly moving it upward. Continue extruding inward while shaping the nose, and at the end, merge it at the center. Then use Loop Tool's Flatten. When you enable X-ray mode, you might notice some faces have a different color. Check the face orientation, and you'll see that those faces are flipped. Fix it by pressing Shift+N to recalculate the normals. After that, continue refining the nose shape. Adjust it from the top, front, and right views. For the center faces, add an edge loop, then shape it into a slight indentation. Select 4 edges, then extrude them outward to the side. For the next part, select 4 corner vertices to create a new face. Then select all the bottom edges while holding Alt and extrude them downward. After that, continue by shaping the eye socket. Extrude the edge at the end, starting from the top, following the reference shape. Then extrude the side parts. Continue with the lower part of the eye socket and connect it with the top section. Next, extrude the center of the eye circle and close the face in the middle. Optionally, you can add an edge across the middle and curve it for more detail. After that, refine the vertex shape of the eye circle. To stay focused, you can hide all vertices except the eye area first. Then extrude the upper part and continue shaping around the eye socket. Create faces for the inner part. For the tip area, it's fine to keep it as triangle faces. Continue refining the topology where needed. Next, select the bottom section. Start by selecting the first vertex, then hold Ctrl to select the next vertices. After that, extrude downward and shape it based on the reference. Continue extruding downward and adjusting the position. Then extrude inward and keep going to gradually close the inner part. Try to keep the mesh topology clean and organized. After that, check how it intersects with other meshes. Make sure the meshes don't overlap too much. You can use Loop Choose Relax to smooth and tidy up the vertices. Here, you might notice that part of the cylinder casing is sticking out. So adjust the crocodile head mesh to better cover and fit around it. After that, let's create the lower jaw of the Crocogun. First, select the face area for the jaw, using the reference as a guide for the boundary. Then duplicate and separate it. Adjust it by moving the middle section downward. Then extrude all the vertices downward. Extrude once more and flatten it by pressing SZ0. After that, shape it into a curved form, like the reference while enabling X-ray mode. Continue by forming the lower jaw into a rounded shape. Once that's done, clean up the topology, even if it doesn't exactly follow the reference. Next, let's create the blade at the front of the lower jaw. First, select, duplicate, and separate the face at the tip of the lower jaw. Add a face on the upper middle part, then extrude it inward and snap it to the lower jaw vertex. Then extrude the face to form the blade length, and for the tip, merge it at the center. Adjust the blade shape from the top and front views. Make it slightly concave and taper toward the front. Then extrude once more for the bottom part and adjust the topology. Fill and connect any empty faces so it blends well with the lower jaw mesh. Finally, refine the shape and adjust the vertex topology to match the reference. After that, continue tweaking so all the meshes fit together smoothly. Next, let's create the teeth. First, decide how many teeth you want to make. For 5 teeth, the current topology is enough. But here, I want to make 6 teeth, so we need to clean up and adjust the topology to fit 6 teeth. Then add edge loops to control the spacing. Here you can decide the style, whether all teeth are the same size, gradually smaller toward the front, or even random in size. After that, select 6 faces as the base positions for the teeth. Now start from the lower jaw, select the inner faces, then duplicate and separate them. Do the same for the head part. After that, select both meshes and extrude them at the same time. Adjust the height of each tooth, then move them slightly sideways if needed. Then scale the tips of the teeth to make them pointy. Then add edge loops to each tooth for better shape control. Then shape them so they curve nicely following the upper part. Next, extrude the outer faces of the teeth to give them more volume. Then select the top of each tooth and merge them at the center. Continue by extruding the top of each tooth and merge them at the center, then snap them using Face Project snapping. Then don't forget to turn off snapping after you're done. Finally, bend the teeth slightly forward and continue refining the topology. Next, let's create the connector at the back of the jaw. We'll start from the crocodile head. First, fill the empty faces, then shape them so they slightly protrude and separate them. Then do the same for the lower jaw. Before that, let's create the connector cylinder at the bottom first. Start from the back part of the cylinder by duplicating it. Then position it according to the reference and duplicate it once more. Select both duplicates and separate them. After that, connect the edge loops using Loop Tool's bridge. Then delete some parts and add a mirror modifier. Next, select two faces on the middle side area, separate them, and hide them temporarily. Then close the remaining faces. After that, join it with the previous mesh. Then delete the faces on the top and bottom cylinder parts. Next, connect the vertices with faces and make sure everything blends well with the surrounding mesh. Continue by cleaning up the topology. Then repeat the same process for the lower part. Now let's move on to the next connector section. Start by duplicating the back circle of the cylinder like before. Then adjust it to match the surrounding mesh topology. Before that, delete part of the mesh and add a mirror modifier. Then separate the two end caps of the cylinder. Connect both circles and form a cylinder. Then closing the ends using extrude and merge at center. Then extrude the top face and tilt it. Add an edge loop in the middle and snap it to the nearby mesh. For now, mirror it to the bottom as well. Then extrude the middle face and adjust it so it fits well without intersecting other meshes. Add another edge loop in the middle and shape it nicely, making sure it doesn't collide with other parts. After that, apply the mirror modifier, delete some faces, and then add the mirror modifier again. Then continue adjusting the lower vertices. Finally, clean up the topology and refine the shape so it closely matches the reference. Next, let's create the back of the Crocogun. Start from the top by extruding and following the curve based on the reference. For the tip, snap it to the nearby mesh. Then continue cleaning up the topology and decide how many spikes or scales you want on the back, just like when we determined the number of teeth earlier. Then adjust it by adding and sliding edge loops. After that, select for faces and turn them into a circular shape using loop tools. Then extrude them and continue shaping according to the reference. Form the spikes however you like, either random for a more natural or stylized look, or more uniform like the handle. Here, I'm keeping them more clean and consistent. Next, let's create the inner wall section. Before that, close the back part of the cylinder casing. Then create edges by connecting two vertex points, separate them, and fill the face. Extrude it sideways and adjust the vertex positions so they match well with the surrounding mesh. Next, let's create the inner pipe. First, add a cylinder with 12 vertices and triangle fan caps, then scale and position the cylinder. Duplicate the mesh and move it to the side. After that, add a Bezier curve to form the pipe. Go into Edit mode, straighten the Bezier by setting the transform pivot point to median point. Then select All, press S to scale, press Y, and type 0 to align it along the Y-axis. Next, snap the ends of the Bezier vertices to each end of the cylinder. Go to the Object Data Properties tab on the right. Then under Geometry, set Bevel to Round and adjust the depth and resolution. After that, you can adjust the scale of each Bezier point to shape the pipe. Then select the pipe, then the cylinder, and press Ctrl+P to parent the pipe to the cylinder. With this way, when you move the cylinder, the pipe will follow. Finally, select both objects and add a mirror modifier on the Y-axis. Then click the arrow icon in the modifier panel and choose Copy to Selected, so the mirror modifier is applied to all selected meshes. Next, let's create the curtain part to cover the pipe. We'll continue from the existing mesh we created earlier. First, close the empty area by filling it with faces. Then add 2 edge loops, depending on how many segments you want. After that, extrude sideways to form a step-like shape, making sure each step has consistent thickness. Then move the 3 edges sideways by pressing G twice, then press C to lock the movement axis. Next, create shape keys to control the movement of each curtain segment. For the first shape key, position the face so the tip aligns with the previous vertex. For the second shape key, duplicate the first one and set the relative to the first shape key. For the third shape key, repeat the same process, but adjust it so the vertices don't overlap. Now let's create the long pipe under the jaw. The method is similar to before, add cylinders at each end. Then use a Bezier curve to form the pipe. Press Ctrl+H to create a hook, then choose Hook to New Object. This will automatically create an empty axis as the hook controller. Repeat the same step for the other end. Now the pipe ends will follow the movement of each empty object. Next, add a child of constraint to each empty object and target it to the nearest cylinder. Before that, separate each cylinder individually. Then set the target again to the cylinder, and don't forget to click Set Inverse. For the other cylinder, join it first with the rest of the crocodile head mesh. Next, create shape keys for opening and closing the Crocogun's mouth. First, select the center tip of the mouth and place the 3D cursor there. Then set the transform pivot point to 3D cursor. Then select the upper head and upper teeth. Rotate them by around -45 degrees, or adjust as needed. Press Ctrl+I to invert the selection. Then rotate the lower part, this time around 35 degrees. After that, adjust the mesh positions so the upper and lower jaws don't intersect too much. Before assigning the child of constraint, create a vertex group first and name it Pin. Select the end of the cylinder where the pipe connects, assign it to the Pin group, then lock the vertex group. To check if the vertex group is correct, you can use the Select and Deselect options in the Vertex Group panel. Finally, set the child of constraint target to the Pin vertex group and click Set Inverse so everything stays in the correct position. Next, let's add shape keys for the other cylinder. Adjust the position and rotation so it matches the jaw opening movement from the shape keys. After that, you'll notice the Bezier pipe doesn't follow the shape key movement properly, so we need to fix the hook setup. Go into Edit mode, then open the Modifier tab if you're not sure which modifier controls each end of the Bezier curve. Click Select on the hook modifier to identify which vertices are assigned. Then fix the end near the blade. Previously, it only used 2 control points. Now we'll use 3 points on the Bezier curve. Select all 3 points, then click Assign on the correct hook modifier. With this, the pipe will follow the shape key movement properly. Next, create a Pin vertex group for the cylinder near the trigger, to use as the target for the child of constraint. Do the same steps as before, and don't forget to set Inverse after resetting the shape key values to default. Now, let's create the ornament that wraps around the pipe. Start by adding a cylinder mesh, then shape it to be slightly rounded and adjust the scale. Add an array modifier and increase the relative offset along the z-axis. For the fit type, choose Fit Curve and select the lower Bezier curve. This way, the array count will follow the length of the curve. Then adjust the constant offset. After that, add a curve modifier and select the same Bezier curve. To make the curve modifier easier to control, make sure the origin of the ornament mesh matches the origin of the Bezier curve. You can control where the deformation starts by adjusting the distance between the mesh and its origin. The modifier behavior depends on the mesh orientation, so adjust the ornament mesh position, especially its rotation. For example, here we rotate the mesh and change the deformation axis in the modifier from Z to X to match the curve direction. Next, let's add another ornament mesh in the middle of the pipe curve. Then copy the curve modifier from the previous ornament and make sure the mesh origin matches the curve origin. Position the mesh toward the middle of the curve by moving it from its origin. Then adjust the topology, as more geometry will give better deformation results with the curve modifier. Now let's try locking the position of this ornament mesh using a limit location constraint. Before that, align the orientation toward the end of the curve. Then add a limit location constraint. Enable all minimum and maximum options, and also enable effect transform. Adjust the maximum X and Z values, then fine-tune the position and scale of the ornament mesh. Next, review and fix anything that still feels off. Don't forget to check the face orientation for all meshes. Also, pay attention to areas like the handle wrap strips. After that, set all meshes to shade smooth. Press A to select all, then right-click and choose Shade Smooth. At first, the result will look messy, so we fix it by adding Mark Sharp to important edges. You can add commands to the Quick Favorites menu by right-clicking a command and selecting Add to Quick Favorites. Then you can press Q to quickly access it. Select Edges, press Q, and choose Mark Sharp. Continue adding Mark Sharp across all meshes. Focus on edges that define the shape of the topology. To remove it, select the marked edges and choose Clear Sharp. While adding Mark Sharp, you can also refine the topology at the same time. Once all Mark Sharp adjustments are done, the modeling stage of the Crocogun is complete. So for the next step, we'll move on to rigging the Crocogun. Alright, let's get started. First, reset all shaped key values back to their default state. Then add a single bone armature. Enable in front so the bone is always visible. Next, switch to edit mode and position the bone. Then rename the bone to jaw. Then go back to object mode and select the jaw mesh. Right-click on Shape Key 1 and choose Add Driver. Then set the type to average value. For the object, choose the jaw armature. Next, for the location type, choose the axis that matches the direction of the armature bone you want to use. Then, to see the bone axis directions, enable Axes in the Viewport display settings. This will show the axis orientation of each bone, making it easier to choose the correct location axis. Next, open a driver tab on the left side, select the same shape key again, go to the driver tab and set the type to Y location. Then change the space to local space. Now select the armature and switch to pose mode. Move the bone along the Y-axis. As you can see, the jaw now moves whenever the bone moves along the Y-axis. So this bone is controlling the shape key value through the driver we added earlier. Next, let's make the bone travel a shorter distance before reaching the maximum shape key value. To do that, add a limit location bone constraint, enable all the options, including affect transform. Then set owner to local space. Copy the travel distance value from the bone position we set earlier. Then paste that value into maximum Y. With this setup, the bone can only move along the Y-axis between the minimum and maximum values we've defined. Right now, however, the maximum bone movement still doesn't produce the maximum shape key value. So next, go back to object mode. Select the jaw mesh, then open the driver tab. Add a Generator Modifier. Then adjust the coefficient for X. Keep adjusting it until the shape key reaches its maximum value. After that, switch back to pose mode and test the bone again. Now, the maximum bone movement matches the maximum shape key value. Next, clear the bone transform and go back to edit mode. Reposition the bone, then test it again in pose mode. You can see that the previous bone settings remain unchanged and everything still works correctly. Now continue placing the bone wherever you want. Next, let's add and set up another bone for the trigger using the same process as before. Here, the bone is placed in the opposite direction because the trigger moves from front to back. Then, rename the bone to trigger. Then repeat the same setup process as before. The Affect Transform option acts as a movement limiter. If it's disabled and you keep moving the bone, even after reaching the limit location boundary, the location values will continue to change. However, when Affect Transform is enabled, the bone location values will stop changing once the limit is reached, so it's generally better to keep it enabled. Next, add another bone using the same method for the fuel tank jaw, with the bone movement directed upward. Next, let's add bones for the barrel section. After positioning the bone, subdivide it so it becomes 2 bones. Then press Alt plus P and choose Clear Parent. After that, press Ctrl plus P and parent the bones again using Keep Offset. Then, rename them to Barrel 1 and Barrel 2. Then add a driver to Shape Key 1 using Barrel 1. And do the same for Shape Key 2 using Barrel 2. Next, switch to pose mode to test them and adjust the bone positions if needed. Then add a limit location constraint. After that, add a Generator Modifier to the driver. Test the bones again in pose mode and reposition them if desired. Next, add a new bone for the curtain cover. After that, point the bone backward, then subdivide it so it becomes 3 bones. Then rename them to Slide Cover 1, Slide Cover 2, and Slide Cover 3. Then separate each bone. After that, parent them again using Keep Offset. Next, add drivers to the shape keys, matching each shape key to its corresponding bone. Then set the movement distance of each bone to the length of one bone by snapping bone 1 to bone 2. Then use the same movement value for all 3 bones. After that, add and adjust the generator modifiers. Finally, test everything again in pose mode. Next, add a driver to the shape key on the long pipe end cylinder. For the driver bone, use the jaw bone. This way, when the jaw opens, the end of the long pipe will move automatically as well. Next, test all the bones again. After that, add a new bone for the handle. Then parent each end bone to the handle bone using Keep Offset. Go back to Object Mode. Select all meshes, then select the armature last. Press Ctrl+P and choose Bone as the parent type. Now test everything in pose mode. When testing, you may notice that the long pipe mesh moves incorrectly and becomes separated. To fix this, add 2 new bones for the cylinders at the ends of the long pipe. Then, place each bone at the hook positions of the long pipe. Then, rename them to Pin 1 and Pin 2. Then go back to Object Mode and select the long pipe. Reassign the hook objects so they use the new pin bones instead. After that, the empty objects are no longer needed, so you can delete them. Test it again in pose mode. Now, you'll notice that the long pipe lags behind when the handle bone is moved. This happens because the pin bones are not parented to the handle bone. Go back to Edit Mode and parent both pin bones to the handle bone using Keep Offset. Now the long pipe follows correctly. However, the long pipe no longer follows the opening movement, so remove the parent relationship from both pin bones again. Then switch to pose mode. Then add a child of constraint to both pin bones. Set the target to the cylinder at the end of the long pipe and use the pin vertex group as the target group. Don't forget to click Set Inverse so the long pipe stays in the correct position. Then, repeat the same process for pin 2. With this setup, the long pipe will follow the other bones properly. However, the ornament cylinder in the middle is not following properly, so let's remove the previous limit location constraint. Then go back to Edit Mode and reposition it to the center. Also make sure the smaller ornament cylinder is properly covered. With this setup, the long pipe will follow the handle bone correctly. Now each end of the long pipe follows its corresponding pin bone. At this point, you can still adjust the shape of the long pipe if needed. Right now, the long pipe follows the movement correctly. However, it is still a Bezier curve object rather than a mesh. Because of that, it cannot use image textures directly. It can only use procedural textures. So if you want to use image texturing, you need to apply all modifiers on the long pipe ornaments first. Then convert the long pipe into a mesh. After converting it, we'll need to rebuild the long pipe rig. Start by deleting both pin bones, then add a new bone, place it to match the shape of the first long pipe end cylinder. Then extrude it along the length of the long pipe. Then extrude once more for the cylinder at the other end. For this end bone, clear the parent relationship. Next, change the bone display type to B-bone. Select all bones and adjust their size. Then position the end bones so they match the cylinders. Then, rename the end bones to pin 1 and pin 2. After that, select the long center bone. Then, set the segment's value to 32. Then, change start handle to absolute. Do the same for end handle and set it to absolute as well. Then choose pin 1 as the start handle and pin 2 as the end handle. You can also tweak the curve shape if needed. Next, switch to pose mode and add a stretch to constraint. Then set pin 2 as the target. With this setup, the middle bone will stretch toward pin 2. Next, select the pin to bone. Then add a child of constraint. Set the target to the jaw mesh and use the pin vertex group. Then don't forget to click Set Inverse, then do the same for pin 1. With this setup, the bones will follow the shape key movement when the jaw opens. However, the long pipe itself is still not following the bones. So select a bone with multiple segments, then switch to object mode. Then select the long pipe along with its ornaments. Then go back to pose mode. Next, press Ctrl+P and choose Armature Deform with automatic weights. Now, the long pipe will follow the bone movement. Next, you may notice that one of the ornaments extends beyond the intended area. Go into Edit mode and delete that section. You can also see that the pipe is slightly too short and doesn't fully reach the end. So let's adjust its length in Edit mode. Then select the circle at the end. After that, press G twice, then press C. This will display a guideline. Then adjust the length until it fits properly. Next, let's create the reload animation. This animation will later be driven by bone actions, so moving a bone will trigger the reload sequence. Then add a dope sheet tab below the playback timeline. Then enable use timecode to replace the frame numbers in the dope sheet. Then set the animation length. Here, we'll use 30 frames. After that, enable auto keying, so keyframes are created automatically whenever a bone is moved. First, select the trigger bone, press I to insert a keyframe, and make sure you're on frame 1. Next, move to frame 5. Then, move the trigger bone backward. Auto keying will automatically create the new keyframe. With this, the trigger animation is complete. Next, let's animate the jaw and fuel tank jaw opening. Add the starting keyframe at frame 5. Then create the open position keyframe at frame 15. This way, after the trigger animation plays, the jaw and fuel tank jaw will open automatically. Next, let's animate the curtain cover so each section moves one after another, starting from frame 15. Begin with the first bone. Add a keyframe at frame 15, then move it and create another keyframe at frame 20. Then move on to the second bone. Then add the starting keyframe at frame 20 and create the moved position at frame 25. Do the same for the third bone. Start at frame 25, then move it, and create the next keyframe at frame 30. With this setup, the animation starts playing after the jaw opens. Next, let's animate the barrel cylinders. For the first cylinder, create the starting keyframe at frame 15. Then move it and create the next keyframe at frame 23. For the second cylinder, start at frame 23. Then move it and create the next keyframe at frame 30. With that, the reload animation is complete. Next, let's add interpolation effects to the keyframes. For example, on the jaw and fuel tank jaw keyframes, select both keyframes, then press T in the dope sheet and choose one of the dynamic effect interpolation options. Start with back. If it doesn't feel strong enough, try bounce. You can see that the jaw now overshoots and bounces slightly after opening. However, the bounce feels a bit too excessive, so let's try elastic instead. The motion feels snappier and more impactful. This works especially well for rigid objects like the metal parts of the Crocogun. Next, apply similar effects to the other bones. For example, the curtain cover bones and the barrel cylinder bones. The barrel cylinder animation already feels good. However, the curtain cover feels a bit slow. So let's change its interpolation to back. Now the motion feels faster and more responsive. Then, do the same for the trigger bone. However, the dynamic back interpolation feels a bit too fast, so let's change it to linear interpolation instead. Next, try moving the ending trigger keyframe further to frame 7. Now, the trigger animation feels more in sync with the rest of the motion. However, it now feels a little too synchronized with the jaw animation, so let's change the fuel tank jaw interpolation to bounce. This gives the animation a bit more character and makes it feel more interesting. Finally, change the dope sheet mode to action editor. Rename the action to trigger activation. Then enable fake user. After that, click the X button next to the action name. Don't worry, this won't delete the animation. Once everything feels right, go back to edit mode. Then, add a new bone that will act as the controller for the animation we created earlier. Then, adjust its position and size as needed. Then parent it to the handle bone using Keep Offset. After that, switch to pose mode and disable auto keying. Next, select the jawbone and add an action constraint. Then, set the target to the new controller bone. You can also rename the controller bone to match the animation name if you prefer. For the channel, choose how you want the controller bone to drive the animation. Here, I want the animation to be controlled by the Y location of the bone in local space. Then change the maximum range value to 1. Next, assign the animation action we created earlier. Set the start and end frames to match the animation range. Now test the controller bone by moving it along the chosen axis. You'll see that the jawbone now plays the animation automatically. Before going any further, add a limit location constraint to this controller bone. Then, set maximum Y to 1 and use local space. Next, copy the action constraint to all the bones that have keyframes in the animation. With this setup, moving the controller bone will drive all of the animated bones at the same time. Now let's shorten the controller movement needed to reach the end of the animation. Set it to the distance you want. Then, go back to the action constraint and adjust the maximum value. Then remove the old action constraints and copy the updated one to the other bones. With this setup, the controller bone only needs a shorter movement to reach the full animation. Next, let's make the handle wrap strip move when the Crocogun is animated. Go into Edit mode and add a new bone, then change the bone display type back to the default display. Position the bone inside the handle wrap strip. Then extrude it until you have a chain of 4 bones. After that, parent the first bone to the handle bone using Keep Offset. Then rename the bones as needed. Next, switch to pose mode and select the last 2 bones at the tip. After that, add a damped track constraint, then set the influence value to 0.75. Then move to the third bone and set its influence to 0.5. Now test it by playing the animation and moving the first bone. You'll see the chain starts to swing and follow the motion. Then reset it using Clear User Transform and repeat the last action with Shift+R. Here, we're only placing the bones in the middle area between the 2 handle wrap strips. Next, switch to Object mode and select the handle wrap mesh. Then return to Pose mode. Select the swinging bone chain and parent it using automatic weights. Now, the handle wrap strip will follow the bone movement. Then, what if we use the setup on both strips? The result becomes messy and harder to control. So in my opinion, using only one bone chain is enough. Next, change the bone display type back to B-bone and adjust the scale. Finally, let's test the full animation. Move the action controller bone from frame 1 to frame 30. Then play the animation and move the Crocogun using the handle bone. With that, the rigging process is complete. Next, we'll move on to UV unwrapping using the UDIM Workflow. Okay, let's get started. First, switch to the UV editing layout. Then start by selecting one of the meshes. Separate any mesh parts that can be separated. Next, move on to the long pipe. Before making any changes, make sure to temporarily disable the child of constraints. After separating the mesh, enable the child of constraints again and update them if needed. Next, we can organize the meshes into groups based on their location, although this step is optional. After that, add a mirror modifier to any mesh that doesn't already have one. This will ensure the texture remains symmetrical on both the left and right sides of the mesh. Next, for the fastest UV unwrapping method, we could simply select all meshes. Then switch to Edit mode. Press U and choose Smart UV Project. Adjust the island margin value, then click Unwrap. Blender will automatically unwrap and map all the meshes. However, since this model contains many separate meshes, we'll use a UDIM workflow instead. So let's start with the head. Begin by selecting edges on the mesh. These edges will become the cut lines for the UVs. Place them in areas where the mesh can naturally be split. The process is similar to adding mark sharp edges earlier. After selecting the edges, press U and choose Mark Seam. Then unwrap the mesh by pressing U and selecting Unwrap Angle Based. The unwrap result will appear in the UV editor on the left. Next, move on to the fangs. Here, I'm trying to unwrap them in a way that avoids any UV stretching. If you notice any stretched faces, try fixing them by pressing Ctrl+T to triangulate the face. Then select all mesh faces. After that, unwrap the mesh again. Once you're satisfied with the result, you can convert the triangulated faces back by using triangles to quads or by pressing Alt+J. However, it's always a good idea to remember the original topology beforehand. The result from triangles to quads may not always match the original topology perfectly. Then, continue adjusting and fixing any areas that still need improvement. Once everything looks good, use Average Island Scale. This will normalize the texel density across all UV islands. Then, if you want to organize the UV layout automatically, use Pack Islands. Adjust the margin value, then click Pack. This will arrange the UV islands automatically. Next, let's add a checker map. Here, I'm using the UV Toolkit add-on. Adjust the checker size and choose the pattern type you want. After that, click Create Checker Material. This makes it much easier to spot stretched UVs. If the checker lines appear bent or distorted, it means those faces are experiencing UV stretching. Once you've finished checking the UVs, you can disable the checker map or switch back using Toggle Material. Next, you can see that a single UV tile is only enough for the head section. So let's add more UV tiles. To do that, add additional tiles along the X and Y directions. Adjust the number based on your needs. For this project, I'll add 5 tiles horizontally and 3 rows vertically. Then, you can still arrange the UVs automatically by using Pack Islands. Just enable Pack the closest UDIM before packing. Next, move on to the lower jaw mesh. Follow the same workflow as before. Start by selecting the edges where you want the UV cuts to be. then mark them as seams. After that, unwrap the mesh. Check the result and fix any stretched faces if needed. Once everything looks good, move the UV islands to the next UDIM tile. Then organize the UV islands automatically by enabling closest UDIM packing. Then, adjust the layout manually, if necessary, to make better use of the available space. After that, create a checker map and inspect the UVs for any stretching or distortion. Next, repeat the same process for the remaining meshes. Then continue by marking the seams, unwrapping the mesh, checking for stretching, organizing the UV islands, and verifying everything with the checker map until all meshes are properly unwrapped. After finishing the UV unwrapping process, let's continue by fixing the mesh shading. If some marked sharp edges are not placed correctly, you can remove and adjust them. Pay special attention to areas such as the claws and fangs. Then, the same applies to the long pipe. If it's difficult to achieve smooth shading using Shade Smooth alone, try using Shade Auto Smooth instead. Then, go to the modifier settings. After that, enable Ignore Sharpness, then adjust the angle value. Keep adjusting it until the shading on the long pipe appears smooth and clean. Then do the same for the smaller pipes. With that, the UV unwrapping process is complete. Next, we'll move on to the texturing stage, combining hand-painted details on specific areas with Blender's texture generation features using Ucupaint. Okay, let's get started. First, switch to the Texture Paint workspace, then select one of the meshes. We'll start with the head mesh. Then open the Ucupaint tab, choose the emission workflow and enable alpha. After that, select all the meshes, then press Ctrl+L and choose Link Materials. This way, all the meshes will share the same material and texture setup. Next, add an ambient occlusion generated layer. Then switch to Texture Paint mode. Create a new image layer. Then for the texture resolution, I'm using 1024 pixels. Higher resolutions will produce sharper texture details. Before we start painting, set the reference image opacity back to full so we can clearly see the original colors. Now, let's start painting the head mesh. Press Shift+X to sample a color from the reference image. Then fill the entire mesh using the fill brush. Next, switch to Edit mode. Then select the mesh faces that will use a different color. Then go back to Texture Paint mode. Enable Paint Mask so only the faces selected in Edit mode can be painted. Now apply a different color using the color palette. Then, continue the same process for the remaining face groups on the mesh. Then, once the head mesh is finished, repeat the same workflow for the rest of the meshes. Once you've finished applying the base colors, let's add an edge detect generated layer. Then change the color blend mode to dodge. Adjust the radius value to get the edge highlight you want. Next, let's remove the edge detect effect from the bright green meshes. Start by adding a masked layer to the edge detect layer. Use a solid white mask as the default. Then switch to edit mode. Select all the faces on the pipe mesh, then fill the mask with black. This way, the long pipe mesh won't be affected by the edge detect generated layer. Then, repeat the same process for any similar meshes. Next, add a fake lighting generated layer. Add a color ramp modifier. Then adjust the colors to your preference. Then change the color blend mode to multiply. After that, add a hue saturation modifier. Then tweak the values until the result works well as the shadow color for your base texture. Next, duplicate the fake lighting layer. Then reverse the light direction from the previous one. You can use layer preview mode to display only the currently selected texture layer. Finally, adjust the hue saturation value so the duplicated layer looks like light coming from above. Next, add a Voronoi generated layer. Then add a mask to the layer and set it to solid black with full transparency. Then fill the mask with white on the head mesh. Then continue with the Crocogun's back mesh. After that, adjust the Voronoi layer settings. Add a color ramp modifier to convert the layer into black and white. Then change the layer blend mode to overlay. Then set the coordinate type to object. After that, continue adjusting the Voronoi settings until you're happy with the result. Place the Voronoi layer below the edge detect layer. Next, add a mask to the fake lighting layer. Remove its effect from the bright green meshes. Then do the same for the second fake lighting layer. Next, duplicate the Voronoi layer. Then adjust the Voronoi settings again to create a more interesting crocodile skin pattern. After that, duplicate the base color layer. Add a hue saturation modifier. Then add a gradient mask layer. Then set the mask coordinate type to generated. Then change the layer blend mode to subtract. Continue adjusting the hue saturation values until you're satisfied with the gradient. Finally, rename the layer to Gradient. Next, let's create the wood texture for the handle. Start by adding a wave-generated layer, then add a mask so the effect only applies to the handle grip. Adjust the wave layer settings until you're happy with the wood grain. Then, rename the layer to Handle. Next, duplicate the handle layer. Remove its effect from the handle grip. Then apply it to the handle wrap instead. Adjust the wave layer settings to create a different wood pattern. After that, rename the layer to Wrap. Next, add another wave-generated layer. Then set the layer coordinate type to Object. After that, set the color channel to Soft Light. Next, add a mask. Then remove the effect from the areas that already have a wave texture, such as the handle and the handle wrap. Also remove it from the fangs or claws, the crocodile skin, and the bright green meshes. After that, adjust the layer opacity to get the look you want. Finally, continue refining any areas that still need improvement, such as adding a subtle wave texture to the shadowed face areas. Next, duplicate the wave layer, then disable the original wave layer. After that, change the wave source to Voronoi. Then, adjust the settings until it creates a grunge-like texture. Then tweak the layer opacity to match the look you want. Both the grunge layer and the wave layer are optional. The grunge layer gives the mesh a more worn and weathered look. The straight line wave layer gives the Crocogun a cleaner and more solid appearance. You can also enable both layers at the same time if you prefer, so feel free to choose whichever style fits your project. For this tutorial, I'll be using the straight line wave layer. Finally, take some time to inspect the texture and refine anything that still feels off. For example, you can lower the opacity of the handle layer so it blends more naturally with the base color. After that, create a new image layer and name it Paint. This layer will be used to manually paint the flowing fuel texture on the bright green meshes. Let's start with the long pipe mesh. First, paint over it with a darker green base color. Then paint a bright green line through the center of the pipe. For the bottom area, use a blue color created by adjusting the hue and value of the darker green. If the blue color doesn't appear and still looks dark green, temporarily enable Layer Preview mode so you can see the true color of the paint layer. Then soften the transitions between the colors by sampling the existing colors and painting along the borders where they meet. After that, adjust the layer order until you get the color combination you're looking for. Next, use brighter colors to paint glowing liquid flowing through the pipe. create two highlight colors, a yellowish green and a bluish green, both based on the previous bright green color. Here I'm using the Paint Hard brush to create sharp, clean strokes. Start by painting the liquid flow with the yellowish green. Then paint the center of each liquid blob with the bluish green. Finally, switch to the Paint Soft brush and add a soft bluish green glow around the edges of each liquid blob. Once the long pipe is finished, move on to the small pipe. Here, I want the texture on this mesh to stay symmetrical even without using a mirror modifier. To do that, use the Mesh Symmetry tool in the top right corner of the layout. Mesh Symmetry uses the mesh origin as the reference for mirroring. So first, temporarily move the mesh origin to the center of the mesh. Now, any painting you do will be mirrored automatically based on that origin. Then paint the small pipe the same way we did with the long pipe. Once you're done, don't forget to move the small pipe's origin back to its original position and enable the mirror modifier again. Next, continue painting the glowing liquid on the remaining bright green meshes. After that, you can also add a hue saturation modifier to the paint layer if you want to adjust the texture colors. Finally, continue painting the mesh beside the pipe. This one is painted manually because the mesh is angled, so using mesh symmetry wouldn't be as effective. Next, duplicate the paint layer to create reflected light on the meshes surrounding the liquid inside the pipes. Before we continue, if the painting process starts to feel laggy, I recommend temporarily disabling a few layers to improve performance. Now let's start with the back of the Crocogun. Sample colors directly from the existing texture to keep the lighting consistent. This reflection layer is optional, so feel free to use it only if it fits your style or project. Then continue painting the remaining meshes using the same workflow. Once you're done painting, re-enable the layers you want to keep. Then adjust the opacity of the layers we created earlier until everything blends together nicely. After that, go through all the layers one more time and make any final adjustments. Once you're happy with the texture, the next step is baking. Before baking the entire texture stack, it's better to bake the edge detect generated layer first. If you bake everything at once, the process will take much longer. For example, in my case, baking the full texture stack takes almost 48 minutes. Then you'll notice the result looks different from before baking. As you can see, the edge detect effect becomes thicker and more pronounced. So let's try that again by baking the edge detect generated layer first. Start by baking only the edge detect layer. In my case, it takes about 2.5 minutes. The baked result is also much closer to the original generated version, unlike the previous full bake where the edge detect became much thicker and more pronounced. Once that's done, bake all channels using the same resolution as the image layer. As you can see, the baking process is much faster now, taking around 20 minutes. The baked edge detect also stays much closer to the original because it was baked separately beforehand. However, there's still one area where the baked result doesn't look very good. To fix it, go back and find which layer is causing the issue. In this case, the problem comes from the baked edge detect layer. The easiest fix is to mask out the problematic faces in that area. Before baking the entire texture stack again, it's a good idea to inspect all the meshes, especially the ones using the edge detect layer. Once everything looks good, go ahead and bake the entire texture stack one final time. After baking, the same issue appears again on the problematic mesh. This happens because some of the mesh faces are hidden behind or too close to other meshes, causing baking artifacts. So bake the texture again after moving those faces into a clear, unobstructed position. As you can see, the baked result is now clean and free of artifacts. This shows that the position of a mesh face can affect the baking result, especially when using generated lighting textures. With that, the baking process is complete. Next, save the baked texture image. Here I'm saving it as a PNG file. And that's it. The Crocogun texturing process is complete. In the next part, we'll cover how to export the Crocogun to Godot. Okay, let's get started. Before exporting, make sure to apply all the mirror modifiers first. However, a mirror modifier can't be applied if the mesh has shape keys. To solve this, we'll install an additional add-on that lets us apply modifiers even when a mesh contains shape keys. Open Preferences, then go to Get Extensions. Search for and install the Apply Modifier with Shape Keys add-on. This add-on is incredibly useful, so huge thanks to the developer for creating it. Once it's installed, you'll be able to apply mesh modifiers directly from the Shape Keys menu. Before doing that though, let's see what happens if we skip this step. Instead of applying the mirror modifiers, we'll export the model as it is. Export it using the GLTF 2.0 format since it's the best option for the Godot engine. Here, if we try forcing the modifiers to apply during export, the mirror modifier will be applied, but the shape keys on the mesh will disappear. Next, open the Godot engine, create a new project. Choose a project name and select where you want to save it. Then import the exported file by simply dragging and dropping it into the project. After that, double-click the file to preview the 3D model. As you can see, the animations were exported successfully. However, there are still several issues, especially on meshes with multiple shape keys and on the long pipe. These problems are caused by a few different factors, so let's go back to Blender and fix them. Before applying modifiers to meshes with shape keys, keep in mind that the shape key drivers will be reset afterward. So it's a good idea to remember or save the current driver settings before applying the modifiers. Let's start with the head mesh. A list of available modifiers for the selected mesh will appear. Since the head mesh only has a mirror modifier, that's the only one listed. Simply check it and click Apply. Then restore the shape key driver settings just like before. Once that's done, repeat the same process for the remaining meshes. After applying the mirror modifiers to all meshes with shape keys, let's export the model again. Then go back to Godot and create a new folder. Import the newly exported file. As you can see, the meshes with applied mirror modifiers and shape keys are now working correctly. The other meshes are still not applied because we left apply modifiers disabled during export. However, the meshes with multiple shape keys and the long pipe are still not behaving correctly. Even though everything looks fine in Blender, there's still one more issue to fix. The problem is that Godot only supports shape keys whose relative to option is set to basis. So let's go back to Blender and change every shape key to use basis as its relative shape. If one of your existing shape keys doesn't work correctly with relative to basis, simply create a new shape key that does. Then copy and paste the driver from the original shape key. After that, remove the old shape key. Finally, export the model again and check the result in Godot. With that, the shape key issue has been resolved. Next, let's fix the issue with the long pipe. As you can see, it doesn't behave the same way it does in Blender. First, apply the modifiers on both cylinders at the ends of the long pipe. Then export and check the results again. As you can see, the problem is still there. The issue is that Blender's B-bones aren't supported by the Godot engine. So first, clear the parent from the long pipe and all of its ornaments. The solution is to convert the B-bones into regular bones. To do that, we'll install another add-on called the Bendy Bone Toolkit. This is another incredibly useful add-on, so a big thanks to the developer for creating it. Once it's installed, open the B-bone Tools panel. Switch to Edit mode and select the B-bone you want to convert. Then run the convert operation. After the conversion, keep the original B-bone selected and disable its deform option. This prevents the original B-bone from deforming the mesh while still allowing it to function as before. Do the same for both the start and end handle bones. Finally, select the original B-bone and the newly converted bones, then clear the parent relationship. Next, switch back to object mode. Select the armature, the long pipe, and all of its ornament meshes. Then switch to pose mode. Select the long pipe bone along with the handle bone. Parent them using with automatic weights. Now the long pipe and its ornaments will be driven by the bones. You'll notice that the ornament meshes also scale together with the long pipe as the bones move. It's not exactly the same as the original Blender setup, but in my opinion, it's a good enough solution and looks very close to the original. After that, export the model again to test it in the Godot engine. Don't forget to enable apply modifiers for the remaining meshes. After testing, the long pipe still isn't working correctly. So let's fix it by adding a limit scale constraint to the long pipe bone. In pose mode, select the long pipe bone and add a limit scale bone constraint. Set both the minimum and maximum values to 1. You can immediately see the difference between a bone with a limit scale constraint and one without it. Then copy the same constraint to the remaining long pipe bones using copy to selected. This keeps the bones at a constant scale, preventing them from stretching or shrinking as they move. Then export the model again and test it in the Godot engine. After checking the result, you can see it's still different from what we have in Blender. It seems that using B-bones in Blender and exporting them to the Godot engine simply won't produce identical results. That's because B-bones aren't natively supported in Godot. Or maybe there's a better solution that I just haven't discovered yet. So if you know a better way to solve this, feel free to share it in the comments. It might help both me and everyone else watching this tutorial. And with that, we've reached the end of this stylized Crocogun weapon tutorial series. Thank you so much to everyone who watched this video, or even the entire series from beginning to end. I hope I can keep bringing you even better tutorials in the future. If you enjoyed this series and haven't subscribed yet, be sure to subscribe. If you're already subscribed, you can really help support the channel by leaving a like and sharing the videos. Thanks again for watching, and see you next time.